let's imagine that you're sitting in a cafe and you look over at one of the tables next to you and you've got four people sitting here in conversation. Is the guy on the left-hand side, do you think he's funny? What about the woman to the right-hand side of him? Is she attractive? Is she interested in the conversation? Do you think she is a nice person? I expect most of you wouldn't have too much difficulty coming up with a response to these. You can make an automatic first impression, an evaluation from very little information. And this is something in our everyday social observations we're continually making automatic first impressions of others. We do this in a way that we have very little conscious awareness or control over the fact that we're making these judgments. And these first impressions that we make are often very difficult to undo. So our first impressions typically count. They work as a very strong anchor on our subsequent judgment. So if somebody makes an initial bad impression, it's very difficult to undo this often. But not always. There are times when we can correct faulty initial impressions and judgments through being a bit more deliberative, so taking a bit more care to focus on the context and the circumstances and additional information to understand other people's behaviour. So this lecture is going to address two modes of social cognition. So the automatic and then the deliberate. And these are going to be themes that will reappear throughout the entire course. So these are presented in a kind of dual process which really dichotomizes or distinguishes between automatic and deliberate. What we're going to see throughout this course is that it's a bit more of a kind of a messy blend between the fact that we can be highly automatic or highly deliberate. And when we end up being, or whether we end up being deliberate, often depends on our motivation. So do we care enough about understanding the situation correctly to invest the effort to engage in deliberate processing? So these dual process theories argue that cognitive processes are either, on the one hand, automatic, and this is characterized by the fact that it requires no effort and typically occurs without conscious awareness, or deliberate or controlled. So they are effortful. We need to invest some resources, processing resources to do it, and they require conscious deliberation. So we're typically aware of us evaluating or weighing up our different options. So look at the woman's face here, and in less than 200 milliseconds of looking at this face, you would notice basic properties such as the fact that she has dark hair, but also equally as quickly you'd process the emotional state that she's in. So you would process the fact that she's got this slight scowl and then make an automatic inference that she's scowling probably because she's angry. And you might have had a sense that she's about to say something unkind or to begin an altercation. So we're then anticipating future behaviours that she's likely to engage in. And none of this is intended. When you look at that image, you're not planning to assess the person's mood or to make interpretations about their future behavioural states. It's just something that we automatically do. It's effortless, it's quick, and it's based on learned associations that we have of somebody's fearful expression. So we have this inner knowledge. There's arguments of whether it's innate or not, but we have an inner understanding and a knowledge that this facial expression that she's putting on signifies anger. In contrast, if you look at the following problem that's on there, so this problem of mathematical problem 17 times 24, you should immediately and automatically realize that it's a mathematical problem. If I now ask you, is the answer to the equation above 12,609 or 123? You could probably quite automatically and rapidly give an answer to that it's not going to be 123. This is outside the range of possible results. But if you want to work out the actual answer to this, we're going to need to go through a much slower process of using conscious, deliberative processes and knowledge of how to do mathematical equations, and then hold some material in memory to work out the answer. So that's one distinction that you can see between something that's automatic and something that's deliberate. Another classic example would be the contrast between driving a car as a beginner and as an experienced driver. So when you first start to get in a car and you're there with the driving instructor, you would be very conscious of your hand positioning. You'd be very conscious of, particularly in the UK, we only drive manual cars. So learning to use the clutch to find a biting point, that's an incredibly taxing process that you're constantly thinking about, changing these gears. With automatic cars, it becomes a lot easier. But there's still loads of things that you're consciously thinking of. You're paying attention to looking in your wing mirror at the appropriate moments. Whereas once you've learned and you've got sufficient experience driving a car, you generally get in and this process of driving is largely automatic. You're not consciously thinking, oh, I need to check this wing mirror, I need to check which gear I'm in, or where the stick shift is, etc. So automatic processes can be defined as being effortless, but I think the best term that characterizes them is the fact that they're largely reflexive. So in essence, we're making impulsive responses to stimuli, social stimuli in the environment. For a non-social example, you might think of the fact that if you hear a loud sound that goes off, so there's a loud bang to the right of me, I would automatically direct my attention towards that. So I'd turn my head and look at where the source of that sound is. It's not something we consciously process, so we don't think, okay, there's a sound over there, now I'm going to turn my head and look towards the source of it. We automatically do it. The same with if somebody was to throw a ball at you and you were to catch it, we move our arms towards where the ball is coming towards us without automatically thinking of what's the trajectory of this ball, how fast is it moving towards me. Rather than just sitting there passively, we reflexively bring our hands towards it. So we do all this automatically. So why is this advantageous? So why should we process stimuli automatically? And the simple answer is that it's efficient. So if we're navigating through this really complex social world, we don't have the time or the effort to consciously process every single input or detail. So instead we can rely on processing and responding automatically to stuff that's around us. And other examples of kind of more social situations where we might do this is, say if you look at somebody's face, we process elements of their personality traits. If we listen to their voice, you can detect subtle cues of the hostility of someone. So again, if you're listening to someone talk, we're not consciously thinking about what is the tone or the way that they're speaking, but you can automatically pick up on whether somebody is talking to you in an excited way, whether they sound like they're bored, or whether they sound like they're hostile and being aggressive towards you. So being able to pick up on these cues automatically can be really useful for an evolutionary sense of detecting potential threats in the environment without us necessarily needing to go around and consciously attend to every single little cue that's there in the social world. Elements where automatic processing can be problematic is the fact that we can often make relatively superficial consideration of evidence, and we often jump to conclusions that might be inaccurate. So again, I'm going to probably make the argument throughout a lot of this course that our automatic judgments that we come up with, majority of the time are accurate, but there are occasions where we're subject to bias or we're taking heuristics that lead us to make an inaccurate judgment. So on the other end, controlled processing, or sometimes referred to as reflective processing, is by definition effortful. It requires attention and it's under the intentional control of the individual. And what the last bit means is generally what we're doing is directing our attention and directing these processing resources towards some specific goal. So we have some judgment or some decision that we're trying to make, and it's in service of that goal that we're directing our attention towards it and our processing resources towards this. So an example of this in the non-social domain might be if you're in a technology shop and you're choosing between two different products, so two laptops or two mobile phones. in order to make a decision or a judgment of which one is going to be best, you would consciously weigh up all of the different characteristics of these two. It might be something to do with the cost of them, and then work out which one is the most appropriate, which is the best value for you. Another example in a social domain might be if you're an employer and you've got several candidates that you've interviewed for a job position, then weighing up all of the different characteristics of each of these candidates, and maybe potentially discounting the initial first impressions that they made from you. So there might be somebody that turns up and they appear very charismatic. We've had an automatic impression of this. But if we look at their CV, it's not necessarily as strong as the other one. So we might then think about maybe this person is just naturally extroverted, comes across good in interviews, whereas there's other people that I interviewed that might have been a little bit nervous. And maybe in their regular full-time job, they're worth giving a chance. So there we would kind of invest extra effort and think about this decision. So why is it advantageous? Well, it can be useful for solving complex logical problems and also overcoming initial automatic biases that might creep in. The problem with this, though, is that it requires a great deal of cognitive effort and motivation. So for our everyday life, we're not going to invest this level of effort to process. We also have controlled, or what is sometimes referred to as reflective processing. And this is processing that is effortful, it requires attention, and it's under the intentional control of the individual. And what that basically means is that we are consciously choosing where we direct our attention towards. So if we engage in reflective processing, we might direct our attention, our effort, and our resources towards solving a particular problem, or helping us make a certain decision or a judgment. So an example of this in the non-social domain would be, say if you go into a shop and you're deciding on which of two phones do you want to buy, the act of weighing up the different properties of each of these phones, so their specifications, and then incorporating the cost, you would often go through a relatively controlled, deliberative process of deciding which of these phones offers you the best value. Not always the case, but often when you're spending a large amount of money, we probably would do a relatively controlled degree of processing. In the social domain, imagine that you're an employer and you're interviewing a number of candidates for a job role. We have one candidate that comes in, they're very confident, but they don't necessarily have a great CV. You've got another candidate that comes in, they seem a little bit nervous, a bit shy, but they have a fantastic CV and good references. We might use more reflective processing to consider all of the different attributes there with these two candidates in order to weigh up which do you think is going to be the most effective or the best employee for you. Why is this advantage? Well, clearly it can help us when we've got complex or logical problems. It can also be really useful for overcoming biases. So if we learn throughout this course that a lot of the time what we do is make initial automatic judgments, and then we can correct for these. If we have the energy or we're invested enough, we can correct for these initial biases using more controlled processing. One of the problems that comes with this, though, is that it requires a great deal of cognitive effort and motivation. So we need to be willing to invest this effort. And it's also difficult to perform under cognitive load. So if you're doing multiple tasks or it's a stressful situation that you're in certain circumstances, we're just not able to engage in controlled processing, or at least to the degree that we would like to come up with accurate decisions. Okay, one of the things that you might see in some of the readings, or certainly referred to in popular psychology textbooks, is this distinction between sort of System 1 and System 2 thinking. So a lot of this stems from Daniel Kahneman's very popular textbook, it was an international bestseller called Thinking Fast and Slow, and he puts forward these two hypothetical systems of System 1 and 2 that relate to automatic and controlled or deliberative processing. But I think it's important to realize at the outset that these are mental fictions, so they're abstract concepts that he's invented, whereas the reality of this is much more complex. And as we'll see today, we generally go through this sort of gradient in the degree to which we engage in either being fully automatic, a little bit automatic, not so much automatic, or entirely controlled. So it's much more on a kind of gradient basis here. You can see on the table here this sort of gradient of different types of automatic, and so from fully automatic at the top, progressively moving down to processes that we would consider to be fully consciously controlled. And generally intent seems to be one of the core distinguishers. So whether that behavior was carried out with our own volition and intent, or whether it was instigated automatically. So what's going to be a focus of much of the lecture is looking at some of this stuff at the top, of looking at how different types of primes can influence our behaviors. So sometimes we can get primed by stimuli that we don't even notice, so it registers on our senses but we don't have any awareness of it. Other times we can consciously notice that a prime has occurred, but we don't have any awareness how that prime is going to affect our behavior. We might have individual differences in the way that certain concepts or thoughts are activated habitually by us. There's sometimes that we can engage in what's known as goal-dependent automaticity. So we might intentionally start something, but then it proceeds on autopilot after we've begun it. Going all the way down to when we engage in behaviors that we have full conscious control over and full intent. So you can break these up into the sort of red ones are the kind of more automatic processes, the ones in green are sort of more controlled, and then in the middle there's a little bit of a kind of blurred grey line of the sort of goal-dependent automaticity, that a little bit controlled, a little bit automatic. So again, there's no real clear cutoff between these. It's very much a sort of gradient. And if you also consider the neural correlates of automatic and controlled processing, so in other words, which areas of the brain are typically associated with controlled versus automatic processing, you can see that there seems to be clustering of automatic and controlled processes in different regions. Again, it's not so simple that automatic processes only ever occur in this one region and all controlled processing occurs in the other region. But for example, a lot of the automatic forms of social cognition are associated with activations in the amygdala, the ventromedial prefrontal cortex, the laterotemporal cortex, and you also find they're related to the dorsal, anterior cingulate cortex and the basal ganglia. Whereas in contrast, a lot of the controlled processes are associated with activation of regions in the prefrontal cortex, as well as some other regions of the parietal and the medial temporal lobe. So if we've got on highlighted in yellow, these are predominantly automatic processes, whereas in blue we've got primarily controlled processes. Now, the intention here is not for you to remember the association of each of these processes with specific regions. I think if there's one take-home that's important from this, is this understanding that prefrontal regions play an important role in controlled processes. So I don't know if you're familiar with some of the stuff that we covered in previous courses, but there's a lot of literature out there demonstrating that the prefrontal cortex, so this front portion of the brain, is really important for inhibition and deliberative processing and being able to restrict and inhibit impulsive responding. So if you look at patients that have damage to this region, they generally engage in very impulsive behavior. So I think there's one sort of clear distinction that occurs there, and then some of the other differences in activation are a little bit more subtle, or a little bit messier anyway. So one of the easiest ways to illustrate, and certainly one of the ways that researchers typically study automatic processes, is to look at the effect of priming. So you should already be familiar with the concept of priming. It's a technique where exposure to one stimulus influences responses to a subsequent stimulus. And the primes can take the form of most typically presenting a word, They can also be used in other variants of presenting a face as a prime. So these primes can also then be presented in different forms. One of these forms is through subliminal priming. So this is where we present primes for such a brief period that they're presented long enough that we have some degree of perceptual awareness. So for example, our visual system is processing that information, but it's not long enough that we have any conscious awareness of having actually seen the prime. So how can we tell that that's actually happening? So you might present something very briefly, and we're talking typically between sort of 13 to maybe 30 milliseconds, so a very brief period of time. One of the ways that you can tell that it actually is being registered at a perceptual level is if you do, for example, EEG recording and look at the activity in regions of the brain, you can tell that this word is being processed. But then if you ask people, did you observe a word that was presented, they would have no recognition of having seen it. But we can see in some instances that these primes do go on to subsequently influence your behavior, or certainly your emotional response or your affect towards other stimuli. So how does it work? A concept can be activated or primed by the subliminal stimulus to increase activation of associated concepts and potentially affect emotions. So if we think of using a word such as bread as a prime, the word bread doesn't have much of an emotional component to it, so it's not going to have much effect on mood, but it would activate all of the concepts that are related to bread. So it would increase activation of concepts such as butter, toast, sandwiches, etc. So anything that in your own internal representation that you have linked to the concept of bread would get a little bit stronger activated. Okay, let's look at a research example that's demonstrated subliminal priming. And a very seminal study, or famous one that comes from this, is from research by John Barge. So Barge, Chen and Burrows, 1996. And in this study, what they would get participants to do was a pretty demanding, relatively boring task. There was a perceptual judgment task where you're presented on the screen between 4 and 20 circles, and your job as a participant is just to say whether there is an odd or an even number of circles being presented. So you can imagine if you're the participant in this, it's not the most exciting thing to do. It's going to lead you maybe to get a little bit frustrated or a bit bored as you're going through. And certainly by the time you get to trial number 130, you're not having the greatest time. Now, the prime that they introduced into this experiment was either of an in-group or an out-group member. So they presented very briefly, so it's between 13 and 26 milliseconds before each trial, a face of a member that was an in-group, in which case these were white American undergraduate participants that were doing the study. So they might also present a white face, or alternatively they would present what was at the time a kind of out-group member, which was a black African-American face. And we know that there's been research showing that when you present to white undergrad students a black African-American face, that this does lead to an automatic processing or automatic priming of hostility. And this works with any member that we assume to be part of a sort of a salient outgroup. Now, the manipulation here was that after doing 130 trials, there would be an automatic error message that comes up on the computer, and the experimenter would basically say to them, like, look, I'm really sorry, you're going to have to run the experiment again from the start. And they were then interested in measuring what was the degree of hostility that participants experienced in these different conditions. And they found that participants displayed more hostile response when they'd been primed with the outgroup to the black African-American faces compared to being primed with in-group Caucasian faces. So you can look at this two different ways that they rated the participants' hostility. One of these is they asked the experimenter to give an evaluation of how hostile did the participants seem. And then they also asked two independent raters, so people who didn't know which conditions. They didn't know how these participants were being primed. They asked them also to rate the hostility level of recordings of this participant. And what you generally find with this is that whether the experimenter rating on the left or the blind coders on the right hand side, the hostility rating is broken down for the Caucasian prime in white and the African American prime in black, and you get this higher level of hostility with the African American primes, regardless of who is rating it. Another related study, a much kind of simpler one that might demonstrate the influence of subliminal primes, was by Murphy, Monahan and Zuyonk. Presented happy and sad faces very briefly, so again between 13 and 26 milliseconds, and they would present these briefly before the appearance of a Chinese ideograph. So one of the ways that this might work is you are shown, or it flashes up on the screen, a smiley, happy face that's here. Then this is paired with a Chinese ideograph, which typically should have, for those that don't speak Chinese, that can't understand what this means, this symbol, this ideograph, shouldn't really have any affective value. So you shouldn't feel particularly positive or negative towards it. Similarly, for other ideographs, they would flash up a negative face followed by the ideograph. Again, the critical thing here is participants, when they're doing this, they don't have any conscious awareness that this happy or sad face is being presented on the screen. Now, if you then ask them afterwards, which of these two different ideographs do you prefer, participants will consistently have a preference for the one that's been paired with the smiling face. So it's kind of indicating there that you are priming this affective, so this positive valence that then gets associated or linked to the ideograph. Another example using similar primes comes from some work of a past colleague at Bangor University. And this shows, I think, some nice sort of applied implications of when you might use these primes, where they got people to cycle on a bike trainer and had them performing a relatively simple task on a screen that was in front of them. So they've got this monitor whilst they're cycling along on the indoor trainer. However, unbeknownst to them, whilst they cycled and they were doing this task on the computer screen, they were being primed with happy or sad faces. So we've got the two images on the screen would be flashed up very briefly for only a couple of frames to a level where we know that they can perceptually process it, but they're not having any conscious awareness of seeing it. And interestingly, what you find in there is that participants that were primed with the happy face as opposed to the sad face ended up cycling further. So in the table it illustrates some of the differences between these two conditions. So there's no difference in the physiological measures. So if you look at blood lactose levels, they're the same. The heart rate during the task is the same. The RP is the rating of perceived exertion. So you ask people, how much effort are you investing in the task right now? How hard is it? There was no difference. But when you look at how far they ended up cycling, being primed with the smiling face makes you capable of cycling further without necessarily feeling more effort. So you can think of there maybe some important implications might come out of this. Of if you're a competitive athlete, maybe you want to use the sort of Google glasses or something that would give you these subliminal primes for a possible edge. There are some caveats to this research that we'll come on to, and I'm not sure how effective this individual study has been in being replicated. But it's an example of the subliminal primal literature that's out there. So what I'd like you to do now, maybe just pause the video and think of what examples you can come up with where you might be able to apply subliminal priming to benefit people's preferences or behavior in real life. And think about what would be an adaptive behavior that you could prime. So rather than using it for evil, what could you use it for possible benefit? So one nice applied example of how you might use subliminal priming is in order to improve people's diets or reduce their desire to consume fatty or sweet foods. So basically things that aren't necessarily good for you. They might be enjoyable. So in one study, they would present participants a fixation cross for 500 milliseconds and then subliminal prime of some stimuli that has a disgust value to it. So in this example, there's the image of a cockroach. You can think of all manner of things that people generally find disgusting, and they would also present those, followed by an image of enticing sweet food. So in this case, you've got a sundae. I mean, my weakness is always the salted caramel ice cream. So for participants doing the study, again, all it's going to look like is that they report consciously seeing the fixation cross, followed by the image of the food. They don't consciously notice this subliminal disgust prime that's in there. But you would notice that this disgust prime would cause activation in the amygdala. So there would be a kind of neural response or a neural register of this. And what you find is if you ask people how much or how excited are they about eating particular foods, their desire to eat these fatty or sweet foods would reduce after you've had these training sessions where they pair this disgust prime with the food stimuli.